Hello my dear students, welcome to ICS Mahesh PU College, Dharwad. Myself Jairaj Hegde. Today let us go for the second part of KCET most important questions with the first part which is already done. Let us go for the second part. Let us go for the question number 31. Which of the following statement is not correct? Whenever such questions are asked, we should have to go for each and every options. There is no other way. We should have to go for each and every options. Let us go for the first option. Copper liberates hydrogen from its acids. We have learned from D and F block elements that the copper is only metal with positive reduction potential. If the metal has a positive reduction potential, it has very less tendency to react with acids. In other words, the metals having negative reduction potential are active metals which readily react with acid to liberate hydrogen. But with copper, as it is having positive reduction potential, it does not react with acid to liberate hydrogen. Of course, a dilute acid to liberate hydrogen. So the first statement itself is wrong. So that's why answer would be option A. Let us go for the question number 32. Which of the following has the maximum number of unpaired d electrons? They have asked the maximum number of unpaired d electron. See, iron Fe2 plus there. Iron the atomic number 26. In its plus 2 state, it has D6 4s0 configuration. Copper plus they have asked. Copper plus in electronic configuration gottida 29 andra 3d10 4s1 hangidra copper plus andre ಏನು ಇರಬೇಕು 3d10 4s0. Zinc is atomic number 30, that means it is 3d10 4s2. And nickel plus 3, nickel atomic number 28 andre 3d8 4s2. If I remove 3 electron, 2 from here, 1 from here, that means 3d7 4s0. They have asked the maximum number of unpaired electrons in d orbital. How many orbitals we have in d subshell? 5. Right? So 1, 2, 3, 4, 5. So d5 would be containing the maximum number of unpaired electron, and the next electrons they start pairing. So d6 it contains 1, 2, 3, 4. So it contains 4 electrons. Right? Next we have d7. So it contains 3 unpaired electron. d8 would contain 2 unpaired electron. d9 would be 1 and d10 would be 0. So these have 0 unpaired electrons, right? And the maximum number of unpaired electrons would be Fe2 plus. See, go with a simple shortcut. Calculate the d configuration, d5, d6, d7, and we have 5 fingers: d1, d2, d3, d4, d5. d6 just close one finger, so 4 unpaired electron. d7 3, d8 2, d9 1, and d10 0 unpaired electrons. Answer is option A. Next question. Among nickel tetracarbonyl, tetracyanonickelate 2 and tetrachloridonickelate 2 complex. See, we can go with easy shortcut that NiCl4, as chlorido is a weak field ligand. As chlorido is a weak field ligand, it usually forms, as it is 4 coordinated, it forms tetrahedral. Cyanide is a strong field ligand, so that's why it should have to form. Here the oxidation of nickel is +2, here also nickel +2, 4 coordinated, and it is strong field ligand. As it is strong field ligand, the coordination number is 4. It has formed square planar. But there is a problem with nickel tetracarbonyl. It is an exception because the oxidation state of nickel is not +2 here, it is 0. So that's why in nickel tetracarbonyl, these two you have learnt it in theory. This is paramagnetic because the hybridization is sp3 and this is diamagnetic, hybridization was dsp2, right? But the problem with nickel tetracarbonyl is the electronic configuration of nickel is as it is in D0, nickel is in 0 oxidation state. It has 3d8 4s2 1 2 3 4 5 6 7 8 4s2. Here it undergoes sp3 hybridization 3d 4s. As the carbonyl ligand is a strong field ligand, we have 3 p orbitals, 4 p, px, py, pz, 4 p orbitals, 3 orbitals vacant. As the carbonyl, 4 ligands are there, they are very much strong field. They makes nickel to pair against the Hund's rule. So then all of these orbitals gets paired, right? 1 2 3 4 5 6 7 8 9 10, and it undergoes sp3 hybridization. It undergoes sp3 hybridization. So that's why it is diamagnetic and sp3 hybridized. This is a very important point as well as a exception you need to know. It is having sp3 hybridization and diamagnetic. So the option would be NiCO4 and NiCN4 2 minus are diamagnetic and NiCl4 2 minus is paramagnetic. The correct answer is option C. Next question. The complex used as an anti-cancerous agent. You have learned it in your first chapter of first PUC as well as D and F block elements that the most important compound which is used as anti-cancerous agent is cisplatin. What is cisplatin? Cisplatin is nothing but diamine dichlorido or cis-diamine dichlorido platinum 2 complex, right? So here cis diamine dichlorido, here it is K2 ಕೊಟ್ಟಿದ್ದಾನೆ, so that's why it is not sodium carbonate. How the trans compound is not, but here he has given a 6 coordinated system and it is a square planar complex. The answer is option A, cisplatin, right? Next question. The Brownian moment is used to the Brownian moment is due to. So why does the Brownian moment takes place? Because the Brownian moment is because of continuous collision between dispersion medium particles with dispersed phase particles. The continuous bombardment of dp particles with dm particles. Right? Let us see which of the option is right. The first option, enthalpy change during the formation. No. The second option, attractive force between the colloidal particles and the molecules of dispersion. No, it is not attractive force. It is the impact of molecule or the collision of molecule of dispersion medium on colloidal particles. Colloidal particles are nothing but dispersed phase particles. Right? Next question. Which one of the following is not applicable to the phenomenon of adsorption? What is adsorption? Accumulation of particles on the surface of solid or liquid. If the particle is accumulated by their willing, that means delta G is negative because it is a spontaneous process. Delta G is negative. The gases are completely free. When they come and accumulate on them, the randomness of gas particles decreases. Correct? Randomness decreases. If the randomness decreases, delta S is also negative. There is a decrease in the entropy. Right? As there is a bond formation between the adsorbate and adsorbent. As we know, always bond formation is exothermic. If the bond formation is exothermic, the energy will be liberated. That means delta H also should be negative. Remember, all thermodynamic quantities are negative for adsorption. So that's why the correct option would be here delta H is greater than 0. It is the wrong one, so that's why it is the correct option. Gibbs free energy less than 0, entropy less than 0, enthalpy less than 0. All are negative. Next question. The rate of the reaction is expressed in different ways as follows. They have given a rate of reaction and they have given a differential rate. Based on the differential rate equation, we should have to find out from what reaction it has written. See, what we know, A moles of A reacts with B moles of B if it is giving rise to C moles of C and D moles of D. If this is the reaction, how we gonna write it? Differential rate equation, rate will be is equal to, as the reactant is there, we should have to write minus, and whatever the coefficient is there, it is to be written at the denominator. 1 by A into dA upon dt, which should be equal to minus 1 by B dB upon dt, which must be equal to, these are the reactants which must have to have negative sign because its concentration is decreasing, which must be equal to plus 1 by C dC upon dt, which must be is equal to plus 1 by d upon dt. Correct? Hangidra they have given plus 1 by 2. Then it must be what? 2. As we have positive sign, it must be the product 2C. Plus minus 1 by 5 dd. Correct? Hangidra minus 1 by 5 then as we have minus sign, it must be reactant. So it must be 5D. Plus 1 by 3. Plus stands for these are the products. Its concentration is increasing. So 3 moles of A. So 3A minus dB. Andra there is no 1 by 1. It must be 1. So that's why plus B. So the answer would be 5D plus B gives rise to 2C plus 3A. The option would be B plus 5D gives 3A plus 2C. Option B is the correct one. Right? Next question. A first order reaction is 50% completed in 1.26 into 10 to the power minus 14 seconds. How much time it would take for 100% completion? See, we know first order reaction, the time taken to exactly reduce its concentration, what we call it as T half. So at each time interval, half-life, its concentration exactly reduces to half. As it is independent on concentration of reactant, the T half would be same. Hangidra 1 kg ಇದ್ದಿದ್ದು 500 ಗ್ರಾಮ್ ಆಗಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕು? 500 ಗ್ರಾಮ್ ಇದ್ದಿದ್ದು 250 ಗ್ರಾಮ್ ಆಗೋಕ್ಕೂ ಅಷ್ಟೇ ಬೇಕು. 250 ಇದ್ದಿದ್ದು 125 ಆಗೋಕ್ಕೂ ಸೇಮ್. So the time required for each half is constant. So that's why it go on degrading, but it never completes. Remember, first order reaction never undergoes completion. So that's why time required for the completion of reaction would be infinite. But yet we have T completed for 0th order. For 0th order we have T completion. T completion will be is equal to R naught by K, which is nothing but 2T half. So twice of T half, half-life would be for 0th order for T completion, but for first order reaction it would take infinite time. It never undergoes completion. Next question. Given the limiting molar conductivity as follows. So they have given limiting molar conductivity. We can solve it based on Correlation's law. Hang madodu. So they have given HCl, limiting molar conductivity of HCl, limiting molar conductivity of NaCl, and limiting molar conductivity of sodium acetate. Nanage bekagiddu yavadu? I want acetic acid. Acetic acid stands for CH3COOH. I want lambda m naught of CH3COOH. Hang barabak CH3COOH. What does that Coriolis law says? Coriolis law says very simple. The limiting molar conductivity of an electrolyte will be equal to sum of individual contribution of ions. Right? Hangidra nanaga H plus beka. It must be equal to CH3COO minus H plus. It is CH3COO minus Na plus Cl minus H plus Cl minus. That means I should have to add these two. Correct? Now what I am having CH3COO minus plus Na plus H plus Cl minus. Hangidra ನಾನು ಏನು ಮಾಡಬೇಕು ಈಗ Na plus Cl minus ಅನ್ನು ತೆಗಿಬೇಕು. How to remove Na plus and Cl minus? By subtracting it by NaCl. So I can do this as lambda m naught of CH3COONA plus lambda m naught of HCl minus lambda m naught of NaCl. So it is what? Lambda m naught of CH3COONA is at 91 Simon centimeter square per mole, and HCl is plus 425.9 Simon centimeter square per mole minus 126.4 Simon centimeter square per mole. ಹಂಗಿದ್ರೆ ಇವೆರಡನ್ನ ಆಡ್ ಮಾಡಬೇಕು, ಅದನ್ನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಡೋಂಟ್ ಡು ದ ಎಕ್ಸಾಕ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್, ಗೋ ಫಾರ್ ರ್ಯಾಂಡಮ್ ಒನ್. 425 plus 100, 91 ಅನ್ನ ಅರೌಂಡ್ 100 ಅನ್ಕೊಂಡ್ರ 525 ಹೌದಾ? ಅದ್ರೊಳಗ 126 ಕಳೆದ್ರ 525 ಅರೌಂಡ್ 400. The nearest to 400 would be 390.5. As it is 100 ಕಿಂತ 100 ಕಡಿಮೆ 10 ಕಡಿಮೆ, so 400 ಕಿಂತ 10 ಕಡಿಮೆ ಇರಬೇಕು. So 390.5 would be the exact answer. Next question. Monoclinic crystal has a dimension. See, this is a typical Bravais lattices. It is essential to remember the different Bravais lattices. Let us have a shortcut. ಈ coordinates na ನೆನಪಿಟ್ಕೊಳ್ಳೋದು, dimensions na ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಬಹಳ important. How to remember this? It is very easy to remember. I will give you a shortcut. C Tom Tra. Remember this shortcut. C Tom Tra. Yena C Tom Tra andre C stands for cubic, T stands for tetragonal, O stands for orthorhombic, M stands for monoclinic, T stands for triclinic, R stands for rhombohedral, and H stands for hexagonal. See, remember a point. This is most unsymmetric. Triclinic is most unsymmetric, cubic is most symmetric. How to remember the dimension? See, cubic, let us have a shortcut. A equal to B equal to C. A equal to B equal to C. Here A equal to B but not equal to C. One equal alla. Either A is not equal to B is not equal to C. Repeat this. Idna repeat madbedi. A is not equal to B is not equal to C. A is not equal to B is not equal to C. Again repeat the first times. A equal to B equal to C. A equal to B which is not equal to C. For angles, this is the sides. For angles, therefore this is, as this is most symmetric, alpha equal to beta equal to gamma equal to 90 degree. This one tetragonal, same, repeat this thrice. Alpha equal to beta equal to gamma equal to 90, alpha equal to beta equal to gamma equal to 90. For monoclinic, one is not equal. ಅದ್ಯಾವುದು gamma. Alpha equal to gamma equal to 90, but beta is not equal to 90. ಒಂದಷ್ಟ equal ಇರಂಗಿಲ್ಲ. Triclinic ಈಗ this is most unsymmetric. Alpha is not equal to, beta is not equal to, gamma is not equal to 90. See, rhombohedral is what? Rhombohedral is similar. Rhombohedral is similar. Alpha equal to beta equal to gamma, but they are not equal to 90. Alpha equal to beta equal to gamma, but they are not equal to 90. And hexagonally alpha equal to beta is 90 degree, but gamma hexa barbeku andre hexagonal barbeku andre bond angle must be 120. So this is the hint which is given. They have asked it for monoclinic. Monoclinic andre ena alpha is no, a is not equal to b is not equal to c, alpha and gamma equal to 90, beta which is not equal to 90. So that's why answer is this one. Remember, and the most unsymmetric is triclinic and most symmetric is cubic. See, here a equal to b, a is not equal to b is not equal to c, alpha and gamma are 90, beta is not equal to 90. The option is option A. Next question. The two electrodes in K subshell will differ in. What is K subshell? K subshell is the first subshell. K subshell is the first subshell. So in first subshell we have n is equal to 1. If we have n is equal to 1, L must be equal to 0. ಯಾಕಂದ್ರೆ ಫಸ್ಟ್ ಸಬ್ಶೆಲ್ ಅಲ್ಲಿ ಇದ್ದಿದ್ದು 1s ಅಷ್ಟೇ, ಕರೆಕ್ಟಾ? So for s, L will be is equal to 0. If L will be is equal to 0, m should be equal to 0. If m equal to 0, s can be either plus half or minus half. So for K shell or the first shell, the two electrons can differ only by spin quantum number. This is the only possible answer. Next one. The number of photons emitted per second from a source of 60 watt monochromatic light with a wavelength of 633 nanometer. See, what is 60 watt? 60 watts is a unit of power. 60 watts stands for 60 joules of energy is emitting per second. So that's why I can write it as energy E is equal to 60 joules. So total amount of energy emitting per second would be 60 joules. And they have given the wavelength in terms of nanometer. Correct? Hangidra formula gottada, E is equal to h nu, which is nothing but hc by lambda. This gives me energy of one photon. So that's why E is equal to, h stands for 6.63 into 10 to the power minus 34. 6.63 into 10 to the power minus 34 into C value 3 into 10 to the power 8 divided by lambda value we know. They have given 663 nanometer. That means 663 into 10 to the power minus 9. I should have to take compulsorily in terms of meter. Instead of doing this, what I can do? I can write it as, rest everything is same, 6.63 into 10 to the power minus 34 divided by 6.63 into 10 to the power of minus 9. As I am putting the decimal point 2 units left side, so that's why this would be minus 7 into 3 into 10 to the power 8. So this one cancelled. So it would be what? Minus 34 plus 7 plus 8. So it would be what? 1 into 10 to the power minus 34 there plus 8 plus 7. 8 plus 7 would be 8 plus 7 would be 15. So it must be what? 10 to the power minus 19 joules. So energy of one photon is 10 to the power minus 19 joules. I have forgotten 3. So 3 into 10 to the power minus 19 joules. Energy of one photon would be 3 into 10 to the power minus 19 joules. What would be the energy of what number of photons are present in 60 joules? Andre ಏನು 60 joules ಈಗ ಎಷ್ಟು 3 into 10 to the power minus 19 joules ಗೆ 1 photon ಇದ್ರೆ 60 joules ಈಗ ಎಷ್ಟು? If I do cross multiply, I'll get what? 60 divided by 3 into 10 to the power minus 19. 3 ones are 2s are. So it would be 20. 19 ಮೇಲೆ ಹೋದ್ರೆ plus 19. So it would be what? 20 into 10 to the power plus 19 or 2 into 10 to the power 20. The correct option is option D. 2 into 10 to the power 20. Next question. A plot of volume versus temperature curve is given at constant pressure. They have given a Charles law graph, correct? They have given isobar. Here they have asked what is the relationship or what is the order of pressure. If we assume at this particular point, I make this temperature constant. Now temperature constant ಮಾಡಿದೆ ಅಂದ್ರೆ it will become Boyle's law, correct? At this temperature, at this pressure, this is the volume. At this pressure, this is the volume. This pressure, this is volume, and this pressure, this is the volume. From Boyle's law, P is inversely proportional to volume. ಹಂಗಿದ್ರೆ ಪ್ರೆಷರ್ ಈ ಪ್ರೆಷರಿಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವಾಲ್ಯೂಮ್ ಇದೆ, ಈ ಪ್ರೆಷರಿಗೆ ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಇದೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಹೈಯರ್ ದ ಪ್ರೆಷರ್, lower will be the volume. The one with least volume is the one with highest pressure. So that's why highest pressure will be for P4, right? Then P3, then P2, then P1, or P1 less than P2, less than P3, less than P4. So P1 less than P2, less than P3, less than P4 is option C. Option C would be the correct answer. The drain cleaner Drainex contains small bits of aluminium which reacts with caustic soda to produce dihydrogen. What volume of hydrogen at 20 degrees Celsius and 1 bar will be released when 0.15 gram of aluminium is reacts? Whenever such questions are appeared in CET, I recommend you to attempt this at the last, because there is no cancellations. Nodri, aluminium 27 gram ada, 27 gram igu 15 igu, there is no cancellation point. Whenever there is no cancellation points, you try to keep it at the end, because it would be a tedious tedious arithmetic problem. See, let us go and solve this. What is the reaction of aluminium with caustic soda? Aluminium reacts with NaOH in the presence of H2O to form what? NaAlOH 4 times sodium tetrahydroxyaluminate plus hydrogen. To balance this 2 aluminium, so that means 2. So this means so I may require 6 hydrogen. Sorry, 6 hydrogen stands for 3H2. 3H2 ಇದೆ ಅಂತಂದ್ರೆ 3 ಹೈಡ್ರೋಜನ್ ಇರಬೇಕು. It means 3H2O. No, it must be 6H2O. So they have asked the relationship between aluminium and hydrogen. So for 2 moles of aluminium, I will get 3 moles of hydrogen. For every 2 moles, I will get 3 moles of hydrogen gas. Then for 1 moles, it will be what? So it will be 1.5 moles hydrogen gas. For 1 mole of aluminium, I'll get 1.5 moles of hydrogen gas. Right? So in order to calculate the number of moles of aluminium, how to calculate the number of moles of aluminium? I know 27 grams aluminium stands for 1 mole. What it will be for? 0.15 gram will be equal to how much? So, or even I can use the simplest formula, number of moles is equal to weight by molecular weight. It will be 0.15 by 27. So this will be the number of moles of aluminium present in the reaction mixture. Right? Let us try to solve this. Let us try to solve this. Number of moles aluminium would be 0.15 divided by 27. So this number of moles are present. So we know a formula, PV is equal to nRT. Correct? Hangidra, ishtu moles aluminium idre, how much amount of hydrogen gas will be getting? So hydrogen will be what? 1 mole iga 1.5 mole barbeka. Idike ಎಷ್ಟು ಇರಬೇಕು? Into 1.4. So the number of moles of hydrogen will be is equal to 0.15 divided by 27 into 1.5 moles. Correct? So hangidra PV is equal to nRT, or they have asked volume. V is equal to what? nRT by P. So n value is given 0.15 into 1.5 divided by 27. R value is, for as I am taking volume in terms of liter, I will get volume in terms of liter 0.083. 0.083. Right? Into temperature which is given, temperature at 20 degrees Celsius. 25 ಕೊಟ್ಟಿದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ಮಾಡಬಹುದು, 0 ಡಿಗ್ರಿ ಕೊಟ್ಟಿದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ಮಾಡಬಹುದಿತ್ತು. 20 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದಕ್ಕೆ 293 ಕೆಲ್ವಿನ್ divided by pressure is given. So what is the pressure? Pressure they have given it as 1 bar. So 1 bar, right? So what I'll get if I multiply everything? So it is quite a difficult task to multiply this and doing this. It will be very tedious. The answer I would get what I would get is around this much. So answer I would get is 0.2. So it will be 0.2 liter. 0.2 liter. 0.2 liter is nothing but 203 ml. Instead of doing like this, as the options are not near, I can also do this in other way also. That would be far more easier. Another way is very much easier. What is that? I know what moles. So instead of doing like this, I can also do like this. See, 2 aluminium, which is equivalent to 3 hydrogen. Right? 2 moles of aluminium is equivalent to 3 moles of hydrogen. So for 1 mole of aluminium, I'll get 1.5 moles of hydrogen gas. Right? So they have given. This is 1.5 moles is what? 1.5 moles is nothing but 22,400 ml is 1 mole into 1.5. So 1 mole of aluminium ige ishtu barutta. 1 mole andra 27 grams ige ishtu bandre, how much I am having? 0.15 gram. Okay, ಎಷ್ಟು ಬರಬೇಕು? So it is what? 22,400 into 1.5 into 0.15 divided by 27. So it is what? See, if I do this, I can assume it as 15 and 15. So I can write it as 15 into 10 power minus 1, 15 into 10 power minus 2. So it would be what? 15 into 15 into 10 power minus 3. I can write it as 22.4 into 10 to the power plus 3. This and this got cancelled, divided by 27. Right? As the options are not so much near, what I can do? I can cancel these two, 27 and 22.4. So it would be what? 15 into 15. So the answer must be 15 into 15. 225. So the nearest answer would be 225 ml. Which one is the nearest answer? 203 ml. None of the options are nearer, so that's why I can easily pick the correct answer. 203 ml. Let us go for the next question. A precipitate of AgCl formed when equal volume of the following are mixed. So KSP is given. What is solubility product? Solubility product is nothing but the concentration of Ag plus into concentration of Cl minus in a saturated solution is 10 to the power minus 10. This is the solubility product. When does the precipitation occurs? So they have asked precipitation of AgCl formed when equal volume of following is mixed. Precipitation occurs only when ionic product is greater than solubility product. So just multiply the ions. It can produce 1 Ag plus as it is producing 1 Cl minus. Correct? Hangidra E concentration multiply madira. 10 power minus 4 and 10 power minus 7 would be 10 to the power minus 11, which is smaller than 10 to the power minus 10. There we have the powers in terms of minus. Be focused. 10 to the power minus 10 is greater than 10 to the power minus 11. So that's why this is smaller, so it will not precipitate. 10 to the power minus 5, 10 to the power minus 6. Idu ashte Ag plus Cl minus, right? So it would be 10 to the power minus 11. Idu smaller. 10 to the power minus 5, 10 to the power minus 4, right? So 10 to the power minus 5 minus 4 under 10 to the power minus 9, which is larger. 10 to the power minus 9. This ionic product is greater than 10 to the power minus 10. So that's why this is the one which should have the Q precipitate. 10 to the power minus 6 minus 6. 10 to the power minus 12, which is still smaller. So the answer is option C. Next question. The pH of 10 to the power minus 10 m NaOH solution is nearestly equal to. The most common mistake what we do is 10 to the power minus 10, we know a formula. POH is equal to minus log of OH minus. So 10 to the power minus kottidare minus 10 barbeku. So it must be 10. Andra POH 10 bantu andra pH 4. So that mistake we usually do. pH 4 idra acidic agbeku solution. Correct? The common mistake we do is pH 4 barbeku andra POH will be minus, POH will be 10. So pH must be 4. This mistake you don't do, because in this case, as the concentration is very less, very dilute, without solving the problem we can say the answer would be 7. It is very dilute, the answer would be pH would be 7. It is almost near to neutral. But how to solve this? See, if I take NaOH, it gives Na plus OH minus. The concentration of OH minus, its concentration is 10 to the power minus 10 m. So that's why it must contain 10 to the power minus 10 molar OH minus. Along with it, it also contains auto dissociation of water. H2O will dissociates into H3O plus 2H2O will dissociates into H3O plus OH minus. And the auto dissociation or the ionic product of water is 10 to the power minus 7 molar. Andre idrolage 10 to the power minus 7 molar. The total is 10 to the power minus 10 plus 10 to the power minus 7. Don't do it as 10 to the power minus 10 minus 7, 10 to the power minus 17. So it is not like that. It is what? If I take 10 to the power minus 7 common, if I take 10 to the power minus 7 common, it would be what? 10 to the power minus 7 into 1 plus 0.001. So it is what? 1.001 into 10 to the power minus 7, which is almost equal to 10 to the power minus 7. So if I apply POHs minus log of 10 to the power minus 7 would be 7. Right? If POH is 7, pH plus pOH is equal to 14. So that's why pH must be is equal to 14 minus pOH, which is 7, will be 7. The correct answer is option B. Next, the unit of equilibrium constant Kc for the reaction A plus B gives rise to C would be. See, what is equilibrium constant? Kc stands for, it's the active masses of products at equilibrium, concentration of active masses of products at equilibrium by reactants, product of active masses of reactants at equilibrium. Products is there. So the product is concentration of C mole per liter divided by A mole per liter into B, which unit is mole per liter. 1 mole per liter, 1 mole per liter hodre, its unit will be what? Per mole liter male hodre liter, right? The unit will be what? Per mole liter or liter per mole. Simple. What you can do, the simplest way or the simplest shortcut for this is mole per liter to the power number of moles of products minus number of moles of reactants. ಇಲ್ಲಿ 1 mole ಇದೆ 2 mole ಇದೆ, so mole per liter to the power minus 1 would be the shortcut form to get the answer. Next question, the equilibrium constant K1 and K2 for the following equilibria. How to tackle this? As we know, equilibrium constant changes with the representation of equation. See, in the first equation they have given NO plus half O2 gives rise to NO2, and then in the second equation NO2 gives rise to 2NO plus O2. What they have done, the simplest way, in the second equation they have multiplied the entire equation by 2 and they have reversed it. I'll give you the shortcut. But how to do with the procedure? How to do for the procedure? So K1 for the first step is what? Products NO2 divided by NO into O2 to the power half, right? K2 is equal to what? They have given the product is NO square into O2 divided by NO2 square. So what is the relationship between these two? How to do that? What I can do, see, simply I reverse it. ನಾನು ಇದನ್ನ ಕೆಳಗಡೆ ಇದನ್ನ ಮೇಲ್ ಮಾಡಬಹುದು, ಹಂಗಿದ್ರೆ ನಾನು ಇದನ್ನ ಸ್ವಿಚ್ ಮಾಡಬೇಕಂದ್ರೆ ಇದನ್ನ ಏನಂತ ಬರ್ಕೋಬಹುದು? 1 by, right? And if I write it as 1 by K1, I will write it here 1 by K1 will be is equal to what? 1 by K1 will be is equal to NO into O2 to the power 1 by 2 divided by NO2, correct? And here as I am having square, so if I square this entire thing, na idukku en madbeku, square madbeku, I'll get the same thing, right? Hangidre relationship between K2 and K1 will be 1 by K1 square will be is equal to K2, or K2 is equal to 1 by K1 square. So this is the answer. What is a shortcut we can go? This is the old equation and this is the new equation, right? Multiplying to what number I will get old equation. ಇದಕ್ಕೆ ಯಾವ ನಂಬರ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ನನಗೆ old equation ಬರುತ್ತಾ? First I should have to reverse, right? ಇಲ್ಲಿ NO ಇದೆ, ಇಲ್ಲಿ 2NO ಇದೆ, ಅಂದ್ರೆ ನಾನು I should have to divide it by 2. ಹೌದಾ? ಹಂಗಿದ್ರೆ multiply it by half. Then I should have to reverse it, right? because here it is at the product side, there it is at the reactant side. And I should have to multiply this equation. Old equation I will get when I multiply to new equation by minus 1 by 2, right? Minus sign is for switching it and 1 by 2 is for, I should have to divide everything by 2. Hangidre old equation is equal to new equation into 1 by 2. Correct? Hangidre old Kc will be is equal to new Kc into 1 by 2. So old Kc, which is K1, will be is equal to new Kc. So it is K2 to the power minus 1 by 2. So K1 is equal to K2 to the power minus 1 by 2. Or in other words, ನಾನು ಈ ಕಡೆ ತಗೊಂಡ್ರೆ K2 will be is equal to minus ಇದೆ ಅಂದ್ರೆ ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕು 1 by K1 square. So the answer is option C. You can go for this shortcut. Next question. Change in the internal energy for isolated system at constant volume. We know formula in delta U is equal to Q plus W or delta Q plus W. See, what is the change in heat for isolated system? As we know, isolated system stands for adiabatic system. There is no change in the heat. There is no change in the matter as well as no change in the heat. As there is no change in the heat change agilla antandra Q value will be is equal to 0 and volume is constant. If there is no change in the volume, we know a formula, Q reverse work done will be is equal to what? Work done will be is equal to minus P external into delta V, right? P external into delta V. If there is no change in the volume, W also will be is equal to 0. Q is equal to 0. W will be is equal to 0. So that's why delta U must be is equal to 0. The answer is option A. Next question. Which of the following equations correctly represents the standard heat of formation of methane? What is standard heat of formation? Heat of formation is nothing but the amount of heat required or liberated when 1 mole of product is formed from its most stable elements. Hangidre 1 mole of methane must be what? CH4 gas. Correct? Hangidre idu form agbeku andre I need 1 carbon plus 4 hydrogen, but hydrogen will not exist as H, it exists as H2. Hangidre 4 hydrogen beku andre 2H2. Now the question is, so this option I can eliminate. This option na tegedbidabodu. Now I have all of them, I have carbon. Which one is the most stable allotropic form of carbon? You can think it is diamond, but it is not diamond. The most stable allotropic form of carbon is graphite, right? So graphite aiti antandra this is cancelled. So I must have to go with this CH4 liquid, CH4 gas. As we know, methane is gaseous. The correct answer is option C. C graphite plus 2H2 will give CH4 gaseous. Next one. Which of the following is electron deficient? Electron deficient yaudide? If we let us write the structure. pH3 is tetrahedral, hydrogen, and I have one lone pair. But the bond angle is near 90 degree. And it has an excess of electron. It is not electron deficient. C2H6 andrena CC. H. It is an electron precise hydride. SiH4. It is also electron precise hydride. H. There is no electron is excess. What about B2H6? It is diborane. B2H6 I can write it as BH3. For the sake of simplicity, I can write it as BH3 ಅಂತ ಬರ್ಕೊಂಡ್ರೆ boron, hydrogen. To complete its octet, it still requires 2 electrons. Correct? To complete its octet, it still requires 2 electrons because this is 2, 1 bond andre 2 electron. This is 2, 2, 2. Totally 6 electrons. To complete octet, it requires rest 2 electrons. So that's why the answer is B2H6. In the simplest words, what you can account for the electron deficient hydride. The 13 group hydrides are electron deficient. The simplest way, 13th group hydrides are electron deficient. 14th group hydrides are electron precise. 15, 16, 17th group hydrides are electron rich hydrides. They act as Lewis bases. Next question. When aluminium is added to KOH solution, what happens? As we know, aluminium, zinc and tin, these are amphoteric metals. They react both with acids as well as bases to liberate hydrogen. Aluminium, just now we have seen a reaction. Aluminium reacts with base. Acid jote allu base jotege nodidivi. Aluminium reacts with base to liberate hydrogen gas plus corresponding aluminate. AlOH 4 times. I am not balanced. It liberates hydrogen gas. So hydrogen gas must be evolved. Next question. Concentrated HNO3 can be transported in aluminium container. This is because this was a typical question which you can find. Though the aluminium is most reactive and it readily reacts with acid, though aluminium has negative reduction potential and it has very less negative reduction, very high negative reduction potential, so it can be readily oxidized with acids. It reacts with dilute acid. However, it doesn't react with concentrated nitric acid. Why? This is because aluminium forms a stable passive oxide layer. Aluminium becomes passive with concentrated HNO3. However, with dilute HNO3 it reacts. With concentrated HNO3, aluminium forms a passive oxide layer. Option B is the answer. Next question. Why are potassium and cesium is used rather than lithium in photoelectric cell? What is photoelectric cell? Photoelectric cell alli ಏನು ಆಗಬೇಕು? Ejection of electrons must have to take place. ಹೌದಲ್ಲ? From metal should have to give electron plus M plus. If the electron is eliminated, the one where the electron easily comes out, that compound with that element which should have to use. ಯಾವುದರಿಂದ electron easily ಸಿಗುತ್ತೋ ಆ ಎಲಿಮೆಂಟ್ ನ ತಗೋಬೇಕು. ಹಂಗಿದ್ರ electron ತೆಗೆಯೋ process ಗೆ ಏನಂತೀವಿ? We call it as ionization enthalpy. Correct? Amount of energy required to remove that electron. If the amount of energy required to remove that electron is lesser, that is more favorable. So right, as we know, lithium, sodium, potassium, rubidium and cesium, as we go down the group, ionization enthalpy decreases. So the one with least ionization enthalpy would be more preferred. So because potassium and cesium has a lesser ionization enthalpy, because of their lower ionization enthalpy. The answer is option A. The same mass of liquid water and a piece of ice is taken. Why the density of ice is lesser than density of water? See, this is because of anomalous expansion of water. Always density of ice is lesser than the density of water, which is from 4 degrees Celsius, it anomalously, its volume starts increasing. The most accepted answer is because in solid state, it forms hexagonal cage-like structure. Due to extensive hydrogen bonding, water in solid state, or in other words ice, forms hexagonal cage-like structure. Because of this hexagonal cage-like structure, the water has lesser volume. A cage iddidakka volume ಜಾಸ್ತಿ occupy ಆಗುತ್ತೆ. So that's why ice occupies more volume. Higher the volume, lower will be the density. So that's why, because of the vacant spaces present in the crystal lattice. Nenepittukori one point, you can connect it to solids. Ice, it has HCP lattice. Ice has HCP lattice, hexagonal cage-like structure, hexagonal close packing. Other drastically cool madbitra, if it is cooled at very low temperature, it gets cubic lattice. This point you can remember. Additional point. Next point. Which one is known as oil of vitriol? It's a direct question. See, H2S2O7 stands for oleum, right? H2S2O7 stands for oleum. H2SO3 is, in common language, it is known as SO2 water or sulfurous acid. H2S2O8 is nothing but peroxydisulfuric acid. Remember, here also oxidation state of sulfur is +6 only. Don't get confused. +7 agangillada. The oxidation state of sulfur is +6, but it has a peroxy linkage. And H2SO4, which we call it as sulfuric acid, is nothing but oil of vitriol, and its salts are known as vitriols, right? Zinc sulfate, white vitriol, green vitriol, blue vitriol, copper sulfate, blue vitriol. Similarly, we will give the names, and the oil of vitriol is nothing but sulfuric acid. The next question: which of the following is a strongest oxidizing agent? Which one is the strongest oxidizing agent? See, among halogens, fluorine, chlorine, bromine, iodine. As we go down the group, electronegativity decreases. As the electronegativity decreases, the tendency to accept electron decreases. Hangidra electron accept modu tendency kadime aatu antandre reduction agu tendency. What is reduction? Acceptance of electron. So that's why accept modu tendency kadime adra reduction agu tendency nu kadime. So that's why it will become, it has less tendency to undergo reduction, or in other words, it has more tendency to undergo, or it has less tendency to do oxidation, right? So that's why the one which has highest electronegative is fluorine. So that's why it has high tendency to accept electron. That means it readily undergo reduction by oxidizing other substances. So that's why fluorine is the strongest oxidizing agent. Remember, in the periodic, in the electrochemical series, the one which is at the top is fluorine. It is the strongest oxidizing agent, and as we go down the group, oxidizing property decreases. The following two reactions, HNO3 with zinc, are given. How to remember this? See, zinc with concentrated HNO3, both the cases it gives zinc nitrate and water. Nerpitgori, illi hydrogen gas baralla. Hydrogen will not oxidize zinc. Instead of hydrogen in HNO3, nitrate ion will reduce. Nitrate ion will oxidize. Nitrate ion acts as an oxidizing agent, not the acid. Remember this point. So we have 4 reactions here. Reactions of copper and reactions of zinc with nitric acid, right? So copper can react either with dilute HNO3 and concentrated HNO3. Similarly, zinc can react with dilute HNO3, concentrated HNO3. The shortcut is what? It is better to remember the shortcut. Dilute, will it react with any metal? If we ask like that, yavataru dilute react agutta? Usually we say no. That is the product. Along with nitrate, the product will be NO, stands for nitrogen monoxide, NO. For dilute nitric acid, the product is NO. For concentrated nitric acid, one the oxygen jasti na, so that's why concentrated idya NO2. So for dilute nitric acid with copper, the product is NO. Concentrated nitric acid with copper, product is NO2. Similarly with zinc also, concentrated, the product is NO2. But with dilute, the product is not NO2, the product is not NO. ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳೋಕೆ the product is N2O. Nitrous oxide, which we call it as laughing gas. Dilute nitric acid ಇದ್ರ N2O ಬರುತ್ತೆ. ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಹೆಂಗ? ZiNC. N extra ಆಯ್ತು ಹೌದಿಲ್ಲ? So that's why one extra. NO ಗ ಒಂದು ನೈಟ್ರೋಜನ್ ಅನ್ನ ಆಡ್ ಮಾಡಿ. The product is N2O. Do you understand? So with copper, concentrated nitric acid, copper and zinc, concentrated nitric acid gives NO2, but dilute nitric acid with copper it gives NO, with zinc it gives N2O. And the last question, noble gases are sparingly soluble in water. That is because, see, noble gases are extremely less soluble in water because noble gases are non-polar. Noble gases are non-polar, and this non-polar gases can also be made in a polar solvent. Already ಇದು polar ಇದೆ ಅಂತಂದ್ರೆ ಅದರೊಳಗೆ dipole ಇರಬೇಕು, ಕರೆಕ್ಟಾ? And it is non-polar, ಹಂಗಿದ್ರೆ dipole ಇರಲ್ಲ, ಅದರೊಳಗೆ induce ಮಾಡಬೇಕು, right? So that's why it is what? Induced dipole or dipole and induced dipole force. The answer is dipole and induced dipole interaction. Between two polar, dipole. Between two non-polar, induced dipole, which we call it as London dispersive force or a dispersive force. Between non-polar and polar species, the force which is acting is dipole, induced dipole. That's for today. Thank you so much. Thank you so much. I wish you all the best for your CET examination. Thank you, one and all.